So good morning all the viewers and especially the candidates of this year 2020. Welcome to your favorite show, Elimu Live on KUTV. So today I'll be taking you through mathematics Form 4, specifically chapter number 4, trigonometry 3. I assure you it will be an enjoyable lesson because it will be all about revision of Form 2 and Form 3. Welcome. So, as you've heard, I'm teacher Atika, Danons High School. So, I want us to very quickly recap of what you did in Form 2 and in Form 3. So, in trigonometry 1, you learned about the SOHCAHTOA. You remember, sine of any given angle theta was equal to opposite over hypotenuse. Then you also talked about cosine of an angle theta was equal to adjacent over hypotenuse. Then finally, you also looked at the tan. Tan theta was equal to opposite over adjacent. Then in Form 3, you learned about trigonometry 2, which had unit circle, angles more than 360 degrees. You also looked at the sine rule and the cosine rule. But specifically, for this lesson, we will be looking at unit circle in Form 3. So, by the end of this lesson, the learner should be able to, 1, these are the objectives of this lesson, derive trigonometric ratio, which is sine squared x plus cos squared x should be equal to 1. Objective number 2, you should be able to solve simple trigonometric equations analytically and graphically. And finally, the third and the last objective of the lesson today, you should be able to deduce from the graph the amplitude, the period, and the phase angle. So, learner, let's look at our first identity, which is sine squared theta plus cos squared theta is equal to 1. We can derive this very quickly. We can derive this, assuming we have our Cartesian plane, we have the x-axis and the y-axis, and I happen to have a right angle triangle. We have angle theta. This is the origin. We have point A and we have point B. So in Form 2, you said sine theta is equal to opposite side to this angle is AB. So I'll have AB over hypotenuse. Let's call our OB R, which stands for radius. So I'll have AB over R. So if I want to get AB, I'll multiply both sides by R. Therefore, my AB will be equal to R sine theta. So our AB is equal to R sine theta. Very good, learner. Then we can also look at the cosine. Cos theta, you remember, cos theta is equal to adjacent. Adjacent side to this angle here is OA. So I'll have OA over hypotenuse. Our hypotenuse is our r here. So you can multiply both sides by r. This r will cancel out. Then our OA will be equal to r cos theta. Very good, learner. So we have our OA, which is r cos theta. Then you remember something you learned in Form 2, Pythagoras theory. You said this side squared plus AB squared should be equal to OB squared. That means if you have r cos theta squared plus then our AB, but our AB is r sine theta. This is sine theta squared should be equal to r squared. Very good. So let's remove the brackets. You'll end up having r squared cos squared theta plus r squared sine squared theta is equal to r squared. You can divide each term by r squared. So if I divide here by r squared by r squared by r squared, I'll end up having cos squared theta plus sine squared theta is equal to 1. So where is this 1 coming from? Because we have divided each term by r squared, r squared, r squared. So of course if I divide here by r squared, this r squared will cancel out. Same to this one, this will cancel out. If I divide r squared by r squared, of course I'll get 1. So this is our first identity in Form 4 that we shall be looking at. Alternatively, from this first identity, you can as well as make cos squared theta the subject of this equation. So you can have cos squared theta is equal to, now you shift sine squared theta to be on the right hand side. So you'll have 1 minus, of course you know this rule, if this sign is positive and shift sine squared theta to be on the other side, the sign will change. So you'll have minus sine squared theta. Alternatively, you can also make sine squared theta the subject. So you can say sine squared theta is equal to 1 minus cos squared theta. So learner, this particular idea will help us towards the end of the lesson when we shall be looking at trigonometric equation. Then finally, we can look at the second identity. You did this in Form 2 where you said tan theta is equal to sine theta over cos theta. So in Form 4, what we are only adding, we are squaring this. You square both sides. If you square both sides, you will end up having tan squared theta is equal to sine squared theta over cos squared theta. So we shall just be playing around these two identities, learner. Make sure you remember these identities. So when I'll be talking about the first identity, you have to know that we are referring to this particular identity. This is the first identity that I'll be talking about. Cos squared theta plus sine squared theta is equal to 1. Then the next identity, the second identity that I'll be talking about is this identity. Tan squared theta is equal to sine squared theta over cos squared theta. So don't forget these two identities. Let's look at an example. You have example 1 if tan theta is equal to A, you have to show that cos theta sine squared theta plus cos cubed theta over sine theta is equal to 1 over A. So this is questions you'll get in section 1 of paper 1 or paper 2, and they carry 3 to 4 marks. So let's get the solution to this. As you can see, we have sine squared here, we have cos cubed here. We can say, let's factor out cos. So I'll have cos theta into brackets. So I've taken this cos theta outside. I'm left with a sine squared theta plus, remember there is we have 3 cos theta here, but I've taken 1 outside, so I'm left with 2. That is cos theta times cos theta, which is cos squared theta over sine theta. So we have to prove that this is equal to 1 over A. So you can just focus on what is on the left-hand side as you prove that if we work out this one, we shall end up having 1 over A. Let's go back to our first identity, sine squared theta plus cos squared theta. We said this is the same as 1. Very good, learner. So if I do away with sine squared theta plus cos squared theta and I replace this with 1, I'll end up having cos theta times 1, which is just cos theta over sine theta. So this is, we can move down. This is the same as, if I have, you have to remember, we are looking at this one here, tan theta, we have tan theta is equal to A. So this tan theta can be written as, let's have tan theta. Let me rub this part first. So this tan theta is equal to A. That is what we have. If I have 1 over tan theta is the same as 1 over A. So you should have this in mind. So cos theta over sine theta can be equal to cos theta over sine theta can be rewritten as 1 over sine theta over cos theta, which is the same as 1 over, what is sine theta over cos theta? From the second identity that we have just looked at, tan theta, which is equal to 1 over, but we had said tan theta, you remember, tan theta is the same as A. So you replace tan theta, you have your A. So we have proved that whatever is on the left-hand side is equal to whatever we have on the right-hand side, which is 1 over A, and that is what we are getting here. So it's all about just playing around with the 2 identities that we have looked at. So we can also look at another example, example 2. Example 2, a very good question here. We have into brackets 1 minus cos theta into brackets 1 plus cos theta over 1 minus sine theta into brackets 1 plus sine theta into brackets is equal to tan squared theta. This is a very good question, 2, 3, or 4 marks in section 1. So, learner, let us remove the brackets. Let's open the brackets. You did this again in Form 2, quadratic expressions. So we shall have this 1 being multiplied by everything that we have inside this particular second bracket. Then once we are done with 1, we shall get back to negative cos theta. You multiply with whatever is inside the second bracket. So let's start by having this one. If you multiply 1 by 1, you will get 1. If you multiply 1 by cos theta, you will get plus cos theta. We are done with 1. Let's move to negative cos theta. You multiply by this, so negative cos theta, you multiply by 1, you'll get minus cos theta. Negative cos theta times cos theta, you'll get negative cos squared theta over, so the same way we have worked the numerator, we shall also apply the same concept for the denominator. 1 times 1, you get 1. 1 times sine theta, you get positive sine theta. Negative sine theta times 1, you get negative sine theta. Negative sine theta times positive sine theta. You did this in Form 1, integers. So negative being multiplied by positive, you get negative sine squared theta. Looking at this, cos theta minus cos theta, so the two will cancel out. Same to this, sine theta minus sine theta, they will cancel out. I'll be left with 1 plus negative cos squared theta. So the overall sign will be minus cos squared theta over, we can move up, yes, there. So we shall have over 1 minus sine squared theta. Let's go back to our first identity. Our first identity, we said 1 minus cos squared theta is the same as? Very good, learner. So we said 1 minus cos squared theta is the same as sine squared theta over, let's look at this, 1 minus sine squared theta. From the first identity, we said this is the same as cos squared theta. Now let's move to the second identity. We said sine squared theta over cos squared theta is the same as tan squared theta. Very good, learner. Therefore, we have proved, remember we were to prove that whatever we have on the left-hand side is equal to tan squared theta. And as you can see, we only considered whatever we had on the left-hand side, and we have maneuvered around the two identities until we arrive at tan squared theta. So those are the two examples from our two identities. So we have another example, example 3. Given that sine theta is equal to 1 over 3, so you are told to work out, you find cos squared theta, part B tan squared theta, part C tan squared theta plus cos squared theta. So I hope, learner, you are writing somewhere, because these are very important chapter or the concepts that you need to have. And I can assure you, you'll get one question from this particular area in your forthcoming KCSE. So we have, let's have the solution to this example. We can have our right angle triangle. We have 90 degrees there. Let's assume that this is our theta. And we are saying sine theta is equal to opposite over hypotenuse. Opposite side to this theta is this one here. So opposite is equal to 1. Hypotenuse is this one here, 3. So you can apply Pythagoras theory to get this particular side. You remember, we can say this squared plus that side squared should be equal to 3 squared. So we can say let that length be x. So we shall have x. Let's move down a little bit. So we can say x squared plus 1 squared should be equal to 3 squared. This is x squared plus 1 is equal to 9. X squared is equal to, shift 1 to be on the right hand side, you'll have 9 minus 1, which is 8. But we need x, therefore you introduce square root on both sides. This square root will cancel out with the square. You will have x is equal to square root of 8. So in short, we are saying our side x is equal to square root of 8. So if you go back to the question they were asking us, we get cos squared theta. So cos squared theta, we can have our part A, which is cos theta. Let's first of all deal with cos theta, because we know cos is equal to adjacent. Adjacent side to this theta is this side, which is root 8 over hypotenuse. Hypotenuse is 3. But our question was cos squared, so we need to square this, and then we need to square that. Therefore, cos squared theta is equal to, the square will cancel out the square root, 8 over, this square is affecting also the denominator, so you have to square 3, you get 9. And that is the answer for part A. Very simple indeed. Let's look at part B. Part B is asking us to get tan theta. Let's get tan theta first, then we shall consider the square part of it later. Tan. SOHCAHTOA form 2. SOHCAHTOA, tan, we said, is equal to opposite side to this angle is this one here, 1 over adjacent side to this angle is our root 8, but we were asked to get the square of tan theta, so you need to square this, you need to square that. So you shall have, if I square 1 squared is 1, the square will cancel out the square root, I'll get 8. And that is our tan squared theta. Very simple indeed. Then part C, you are asked to get tan squared theta plus cos squared theta. Part C is asking us to get tan squared theta plus cos squared theta, which is equal to our tan squared theta. Already we have worked it out, so learner, you should not now go back to our first step. Already we have these values with us. For tan squared theta is equal to 1 over 8. I'll just have it 1 over 8 plus cos squared theta. Already we have our cos squared theta is here. Cos squared theta is equal to 8 over 9. Very good. 8 over 9. So you only need to add these, and as I always tell my students, in math don't do guesswork. So if you don't know, just use your calculator, as I also have mine. 1 over 8 plus 8 over 9. This one gives us, yes, Lana, what are you getting? 1 over 8 plus 8 over 9. My answer here is, I'm waiting for my good student here to get me the answer. So I'll get 73 over 72. And that is my answer for this particular question. So that is the end of that particular example. As you can see, we're just playing around with the identities, the concept that we already have. We did this in Form 2 and in Form 3. So let's move on to the waves. And here, when we talk of the waves, the physicists will bear with us. Now here, you did waves in Form 2 physics. You know, I have to mention physics because it's also a science just like mathematics. So waves, we are looking at the graphs. We'll be having graphs. We'll be drawing some here, and we'll be mentioning some few things that you need to know when you are drawing graphs. So let's start with the amplitude. For you to know, though in math you can't be asked to define, but it's good for you to know what amplitude is, because once you know what it is, then you can apply that particular knowledge to getting the amplitude. You'll be asked to get the amplitude and the period. So amplitude refers to the maximum displacement of the wave above or below the x-axis. So I'll be explaining this using the next example. The period is the interval after which the wave starts to repeat itself. That is the period. And in most cases, the period is always in degrees or in radian. Then the amplitude, that one is like the displacement. So we shall be looking at the units for that. Let's look at an example. You are asked to determine the amplitude and the period of the curve y is equal to 3 sine x and y is equal to sine x from this particular graph. So if you are given this graph learner and you are asked to get the amplitude of the first graph, this one here, 3y is equal to 3 sine x, y is equal to 3 sine x. So this is the graph of y is equal to 3 sine x. That is it. So how do we get the amplitude? As we had said, amplitude refers to the maximum displacement of the wave above or below the x-axis. So the maximum displacement that this wave has gone, the maximum, we are looking at the maximum. This is the maximum point. And as you can see, so the maximum here is 3. That is the maximum. That is the farthest that this wave has gone above the x-axis. So we shall say the amplitude of y is equal to 3 sine x is equal to 3. That is the answer for the amplitude. Let's look at the amplitude of the second wave, this one here. Just follow this wave, follow this wave, follow this wave. The wave of y is equal to sine x. So the amplitude, the maximum, just look at the maximum, the maximum is this particular point. So if you look at my sketch here, the maximum should give me 1. That is the amplitude of this particular wave. So the amplitude of the second curve, y is equal to sine x, is 1. So I hope now you know how to get the amplitude from the graph. Then let's get the period. Remember, we defined the period as the interval after which the wave starts to repeat itself. So let's look at the first particular wave of y is equal to 3 sine x. Let's follow this particular wave. At which point does this curve start to repeat itself? So if you follow this particular wave, you'll realize that this is the point at which this curve starts to repeat itself, because this is the x-axis. We were starting our journey at the x-axis origin. So this is the point where the curve started going up. This is the point. If you follow this particular wave, you'll realize that it started repeating itself at this particular point. So you get the values of x. I don't know if you can see this. The angle at this particular point is 360 degrees. So that becomes the amplitude. And as you'll bear with me, that the period of these two waves, let's look at the second wave. Just look at the second wave. This is the point at which the second wave starts going up. You follow it. So again, it's at the same point where the curve is repeating itself. So that means the two waves have the same period, which is 360 degrees. So we have the period for this 360 degrees, 360 degrees, or you can say 2 pi radian. You did this again in form 3, where we were saying 2 pi radian is equivalent to 360 degrees. So that is what you can be asked. Given the graph, you can be asked to get the amplitude and the period. Remember, we have said the amplitude, you just look at the maximum displacement on either side. Even if you are to use this particular side, if you are to use this side below the x-axis, you will say that the maximum point is at this point. So if you follow it, you'll realize that that is -3. But since I said amplitude is displacement, displacement cannot be negative, so you ignore this negative sign and focus on the positive sides and say amplitude is equal to 3. And if you are to look at the second wave, the maximum point will be -1. You ignore the negative and focus on the positive. So that becomes the answer for that particular question. It's very important to note, sometimes you can be asked to get the amplitude and the period and also the phase angle without drawing. So you don't have the graph, you've just been given a function and you are asked to find the amplitude, the period, and the wave. So this example will help us understand how we can go about such kind of questions. And we have two functions here. Given the function of the form y is equal to k sine bx plus or minus, this can be plus or minus, the sign doesn't matter, or y is equal to k cos bx plus or minus theta. So if you have such functions, they must have sine and cos. Here we are not looking at tan. They must have sine or cos. So for you to get the amplitude is the coefficient of sine or the coefficient of cos, which is k. That is how you get the amplitude. That is how you get the amplitude. You just look at the coefficient, the number that is coming before sine or cos. Take note of that, learner, that to get the amplitude without drawing, you just look at the coefficient of sine or cos. Then for you to get the period, of given function, you will have 360 degrees divided by b, and b is the coefficient of x. So let's look at an example. You are told without drawing, determine the amplitude and the period of the waves y. So we have y, let's have it here, y is equal to cos x. So let's get the amplitude of this particular wave. So we have said for you to get the amplitude, you just look at the coefficient of x. The coefficient, there is a number here that is very silent, and that is 1. It's only that we can't write 1 cos x. So there is 1 here that is very silent. So the amplitude will be 1. So for you to get the amplitude, I'm repeating again, you look at the coefficient of either cos or sine. In this case, the coefficient here is 1. Then let's look at the period. The period, I gave you the formula. Do you remember the formula? 360 degrees over b. And b, I told you it's the coefficient of x. The coefficient, there is a number here that is very silent. Before this x, there is 1. Because in math, you can't write 1x. So you just write x. Because x, if you write x, it means that is only 1x. So there is 1 here that is silent. So I'll have 360 degrees divided by 1. Of course, you know where this 1 is coming from because it's the coefficient of x. So if you divide 360 degrees by 1, you will get 360 degrees. And that is the period for this particular first wave. Let's look at the second wave. Let's look at the second wave, where you are told y is equal to cos a half x. Let's get the amplitude. Let's get the amplitude, Lana. The amplitude, you just need to look at the coefficient of x. Coefficient of cos, sorry, the coefficient of cos here is 1. Then the period, the formula is very important, 360 degrees over b. 360 degrees over b, which will be equal to 360 degrees over b. Our b, we said it's the coefficient of x. And for this question, our coefficient is not 1. As you can see, before this x, there is a number that is appearing, which is 1 over 2. So I'm going to divide my 360 degrees by a half. So if you work out this, you will get 720 degrees. And that is my period. So we don't have the graph for this particular example, Lana, but we are able to get the amplitude and also the period. Next subtopic is trigonometric equations. Trigonometric equations. And here now, that is where we have to be very careful, because it's an area that is always tested. So you have the first example. You solve the trigonometric equation. Sine 2x is equal to cos x. The range of x is given from 0 degrees to 360 degrees. And here I'll take you back to Form 2. As I earlier said, that this is just but revision of what we already know. So in Form 2, we looked at, let me just remind you what we did in Form 2. We were saying that if I have sine theta should be equal to cos into brackets 90 minus theta. That is what you said in Form 2. So these angles are called complementary angles. If you add this theta to this angle here, it should give you 90 degrees. We can give an example. If you have sine, let's give an example of 30, sine 30 degrees. This should be equal to cos into brackets 90 minus theta. Our theta here is 30. So this will give us sine 30 degrees is equal to cos 90 minus 30. That will give us 60 degrees. So even if you use your calculator, sine 30 will give us 0.5. Cos 60 degrees will give us 0.5. That is what we did in Form 2. So now we are going to borrow this knowledge to solve this particular question. And we shall say, let's now get back to our question. Sine 2x should be equal to cos x. But look at this cos x. Cos x, we can say, but cos x can be equal to sine. I've just given you the concept. This is the concept. Cos x is equal to sine 90 minus x. That is the concept. So I'm going to do away with this cos x and replace with this particular knowledge. So I'll have sine 2x is equal to, we can say is equal to sine into brackets 90 minus x. That is the concept. So if I add these, I can say 2x is equal to 90 minus x. I've just equated this angle to that particular angle. Then from there, you can find the value of x. shift this x to be on the left-hand side. This is negative. When it goes on the left-hand side, the sign will change from negative to positive. So I'll have 2x plus x, which will give me 3x is equal to 90. Divide both sides by 3, x alone is equal to 30 degrees. So we have our first value of x, which is equal to 30 degrees. But in form 3, you looked at the unit circle. Unit circle, let me have a sketch of that unit circle, where you said all students take chemistry, and that is maybe the easiest way to remember that particular concept, unit circle. So to get an angle here, we were saying you'll have 180 minus theta. To get an angle here, you are to have 180 plus theta. To get an angle in this particular quadrant, you are to have 360 degrees minus theta. This is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. You did this in form 3, unit circle. That was the subtopic. So it's a very good revision. So since we were dealing with the sign, here, as you can see, so you ask yourself, in which quadrant will you get signs of angles that are positive? So you realize that you have the first quadrant, we have 30 degrees, and you also need to get another angle in this particular quadrant, the second quadrant. So you'll have 180 minus theta. Our theta here is 30, so you'll have 180 minus theta, which is 30. That will give us 150. So in short, we shall be saying our x can also be equal to 180 minus 30. That will give us 150 degrees. So these are our two values or two answers for this particular question. Don't just stop when you get x is equal to 30 degrees. Remember, we were given the range. That our x ranges from 0 to 360 degrees. That is why we are having the unit circle. That is the concept that is going to help us get other angles apart from the acute angles that we shall be getting. Let's look at another example. I'm sure where the challenge is on the unit circle. Some of us have forgotten the concept, but today we are being reminded that we need to revisit that particular chapter in Form 3. Let's look at another example. Wow, very good example here. Solve the trigonometric equation tan 3x is equal to 2. The range of x is given from 0 degrees to 360 degrees. So the solution to this very quickly, because we have a lot to cover, we have tan 3x is equal to 2. Tan 3x is equal to 2. So here we are going to put this 3x aside first of all and focus on getting our theta. So you'll get your theta. You did this again in Form 2. If you have, let's say, tan theta is equal to 2. So to get theta, you are to say theta is equal to tan inverse of 2. So use your calculator to save time, though you can use your calculator or you can as well as use the 4-figure mathematical table, but for this one, you just need to use the calculator to save time. So you shift tan, it will get you to tan inverse of 2. That gives us the tan inverse of 2 learner. What are you getting? You get 63.43 degrees. That is my tan inverse of 2. So here, now you need to go back to the unit circle. I'll be drawing this unit circle here until you get the concept. This is our x-axis. This is our y-axis. You remember we said all students take chemistry. Chemistry is C. So S stands for all trigonometric ratios, angles between 0 and 90 must be positive. Here in this quadrant, only signs of angles are positive. The rest are negative. So the rest we are referring to tan and cos. In the third quadrant, we said this is the first quadrant, the second, the third, and the fourth quadrant. So in the third quadrant, only tans of angles here are positive. The rest we are referring to sines and cos are negative. Then finally, in the fourth quadrant, only cosines of angles in the fourth quadrant will give us positive values, but the rest, sine and tan, will give us negative values. So we are dealing with the tan. So if I was to ask you, our 2 here is positive. In which quadrants will you get tans of angles that will give us positive values? Which quadrants here will give us values of tan that are positive? So we have the first quadrant and we have the third quadrant. If we were to take the second quadrant, it will give us negative. Same to the fourth quadrant, it will give us negative. And that is not the case for our 2 here. Our focus is on this particular 2. 2 is a positive value. That is why we need to focus on the first quadrant and the third quadrant. So we said to get an angle here, it's 180 minus theta, 180 plus theta in the third quadrant. In the fourth, 360 degrees minus theta. Don't forget this particular concept, learner. You did this in Form 3, Trigonometry 2. So since we know we have to get angles in these particular quadrants, the first quadrant and the third quadrant, we already have an angle in the first quadrant. So our theta here, we have 63.43. Let's get the angle in the third quadrant. The third quadrant, how do you get the angle in this particular quadrant? It's 180 plus theta. So you'll have 180. You can even do it from somewhere else. 180 plus theta. Our theta here is 63.43. So you can do that one very quickly, learner. 180 plus 63.43. So this will give us 243.43 degrees. Very good, learner. And since we shall be dividing these values by 3, we can try to go to the second lap, the second round. So here you'll have to add 360, again 360, because now this is the second lap or the second round. Remember the range of x was given from 0 degrees to 360 degrees. So we can try and move on to the second lap. So we shall have 360. I hope you know where this 360 is coming from, because now this is the second lap, not the first lap. So you'll have 360 plus our theta. So you can work out that one. 360 plus our theta, which is 63.43. That will give us, what are you getting, learner? You'll get 423.43 degrees. Let's move on to the third quadrant. You'll have 360, you add to 180, you add to theta. So 360 plus 180 plus theta. Our theta, don't forget our theta, it's 63.43. So this will give us 603.43 degrees. Very good. Let's try and move on to the third lap. So the third lap now, because you know if you make one round, that is 360 degrees. So let's now move to the third lap, 360 degrees, 360 degrees, and see what we shall get. So you can work out this one, 360 plus 360 plus our theta, 360 plus 360 plus our theta, which is 63.43. This one will give us 780 83.43 degrees. Finally, this is the last lap. I'm sure the learners are wondering whether we shall move on to the fourth lap. So this is the last lap. Let's work out this one. You'll have 360 plus 360 plus 180 plus our theta. Our theta, remember, it's 63.43. So this one, it's giving us a 963.43. Remember, this was now this is the point where you need to factor out your 3x. Remember, we had avoided this 3x and we said let theta be equal to 3x. So you can now do away with this and say 3x is equal to all these values. So we need to get the values of x. How do you get the value of x, learner? So you can have this 3x is equal to, take the first angle, which is 63.43. How do you get x? You divide both sides by 3. So x alone, if you divide this 63.43 by 3, you will get 21.14 degrees. That is our first angle. So in short, what we are doing, to get the values of x, we have to divide these values by 3. Where is this 3 coming from? It's coming because we have this 3x here, 3x. So to get x, you divide both sides by 3. So we have to divide these values by 3. Let's try to do that, learner. 243.43 divided by 3, you'll get 81.1. Let me rub this 0.14 degrees, of which we are still within the limits given. Remember, the highest should be 360 degrees. So we are not yet at 360 degrees. So that means we'll have to move on. Now let's now focus on this one here. Divide 23.43 divided by 3. That will give us, very good, learner, 141.14 degrees. If you can look at my answers, you have to maintain the same number of decimal places, 2 decimal places, 2 decimal places, 2 decimal places. Even though the question was not asking us to maintain, it's very good you be consistent. Let's move to the next angle, this one. So you'll have 603.43 divided by 3. I hope you know where this 3 is coming from. It's because of that 3 there. So divide by 3, you'll get 201.14 degrees. What about this one here? You'll have 783.43. You divide by 3, you'll get 261. 261, remember, we are still within our limits. So you'll get 261.14 degrees. And then finally, let's look at this. You have 963.43 divided by 3. This is giving us 321.14 degrees, of which this value is within the limits that we were given. Remember, this is the limits that we are working with. The values of x should range from 0 degrees and the highest being 360 degrees. So looking at all the values of x that we have here, they fall within the range given, 0 degrees to 360 degrees. If we were to move to the next round, I'm sure the values of x would have been more than 360 degrees. That's why I said we can stop there at least for this particular question. So I'm sure there are some students who will just get the value of x and they say the value of x is equal to 63.43. Yet we still have other angles that will give us the same answer. So, learner, We have an exercise here. We have an exercise here. We have an exercise. You can look at this particular question. Yes, my producer is very active here. That is the only student I have because we have to maintain the social distance. So we have one question here. You have the past KCSE question on the topic. You are told to solve equation 4 sine into brackets x plus 30 degrees into brackets is equal to 2. The values of x ranges from 0 degrees to 360 degrees. We can as well as work out this one because I'm sure we have other questions that I'll be giving you. You'll try this one. You'll try question number 2 and also question number 3. So what I can do, I can help you answer this particular question here so that I give you some questions you also try at home. So let's work out this one. Let's work out this one. We can work out this one, learner. So solution to this. Solution to this. Let's get the solution. We are focusing on this particular equation. So the equation here is 4 sine into brackets x plus 30 degrees is equal to 2. Remember the range is from 0 degrees to 360 degrees. Very good. So so here we can divide both sides by 4. By 4, this 4 will cancel out with that. Sine into brackets x plus 30 degrees is equal to a half, because 2 over 4 is just the same as a half. If you simplify that one, you will get a half. So the same way we tackled the first example is the same way we will tackle this example. We can do away with x plus 30 and say, let this be theta. So we can say sine theta is equal to a half. How do we get theta? Theta is the sine inverse of a half. Sine inverse of a half. So you can use the calculator. Theta will be equal to, what is the sine inverse of a half, my student? Sine inverse of a half is 30. These are special angles. We need to know sine, cos, and tan of 30, 60 offhead. So we have 30 degrees. That is our theta. So we shall say, now we need to go back to this particular information that we had said we can do away with it, which was x plus 30. So x plus 30 is equal to, the first angle that we are getting here is 30 degrees. How do you get the next angle? To get the next angle, you'll get back to the unit circle. Unit circle here, we have the x-axis and we have the y-axis. So you remember, all students take chemistry. This is the first quadrant, the second quadrant, the third quadrant, and finally the fourth quadrant. So we are dealing with the sine. We are dealing with the sine. In this question, we had sine. So ask yourself, where will you get sines of angles that will give us positive values, like our 2 over 4? 2 over 4, if you simplify, you get 1 over 2. 1 over 2 is a positive value. So that's why we have to focus on positive values here. So in which quadrants are these that you will get sines of angles that will give you positive values? So it is in the first quadrant, very good learner, and very good, the second quadrant. And here we say to get an angle in the second quadrant, it's 180 minus theta. To get an angle here, though, we will not use this one, but I'm just reminding you, the angle here is 180 plus theta here, 360 minus theta. Very good, minus theta. So since we have to consider only angles in the first and the second quadrant, so we shall have our angle in the first quadrant, which is 30 degrees. Our first quadrant, these are acute angles, angles that range between 0 and 90 degrees. Then in the second quadrant, these are angles that range between 90 degrees and 180 degrees. In the third quadrant, these are angles that range from 180 to 270 degrees. Then finally, in the fourth quadrant, these are angles that range between 270 degrees to 360 degrees. That is one round, 360 degrees. So let's get an angle here. You'll have 180 minus theta. Your theta is 30. Your theta is 30. Don't forget that. Your theta is 30. So you'll have 180 minus 30, which will give us 150 degrees. Let's move to the second round. The second round, just like we answered the first example, so we shall have to add 360 degrees, 360 degrees. So this is the second round. 360 degrees plus our theta, 360 plus 30, you get 300 and, yes, Lana, 360 plus 30, you get 390 degrees. Then in the second quadrant, you'll have 360 degrees plus 180 degrees minus theta. Our theta is 30, don't forget that. You'll get 510 degrees. 510 degrees. So there's no need of you going to the third lap, because if you just look at these values, the range of x. So to get x, for example, to get x, so let's find the values of x. You'll have x plus 30 is equal to the first angle here, which is 30 degrees. So x will be equal to, take this 30 the other side. So you'll have 30 minus 30, which is 0 degrees. So of which x I don't know if you should have 0, because 0 means nothing. So you have nothing there left. So we shall have our x is equal to, let's get the next angle here. So for you to get the next angle, so we have there is a, we can still continue on, Lana. As you work out this, you have x plus 30, you have x plus 30 is equal to the other angle. Then you find the value of x. So here we'll have to at least see what is happening. X plus 30 is equal to 150 degrees. Now you can get the value of x. You can get the value of x here. So you have x plus 30 is equal to 150. You can sorry for that, Lana, there was a very small hiccup, the technology that we are using, so we can continue. I hope now we are okay. I hope now we are okay. We are okay with this one. Now we can go back to what we were doing. Thank you so much for holding on, Lana. So let's get the other angle. I was saying you have x plus 30 is equal to 150. So in short, for you to get the values, you just need to shift this 30 degrees to be on the right hand side. So it means you'll be subtracting 30 degrees from all these angles. Just like we subtracted 30 from 30, we got 0. So you have to subtract 30 from all these angles. So you'll have 150 minus 30. That will give us 120 degrees. What about 390 minus 30? That will give us 360 degrees. So those are the values. If I was to continue with this 510, if you have 510 minus 30, that will give us 480. But 480, Lana, is not within the range given. So 480 degrees cannot be the answer for this particular question, because we are working within the range given, and the range is from 0 degrees to 360 degrees. You can still have your 0, because when we say less or equal, it means 0 is also part of the answer, and here less or equal to 360 degrees, it means this value can also be the answer for the value of x, and that is why we are saying our x is 360 degrees. And I've said you can also have your 0 as one of the answers there. That is the end of that particular question. Now, learner, you can write this somewhere very quickly because we still have one more example, and that is the graph part. We are looking at the graphs after this. So solve for values of x in the range 0 degrees to 360 degrees if 3 cos squared x minus 7 cos x is equal to 6. So you can copy that one somewhere, learner. You will be working out that, and you can send us the feedback. Our dear viewers, we have numbers scrolling at the down of your screens. You can send us your questions, your comments. If you have anything on this particular lesson you want us to comment or you want to improve, please, your ideas are highly welcome. So there's another example, example 3. So you'll write this one somewhere, learner, and you can also attempt find all the values of theta between 0 degrees and 360 degrees that will satisfy the equation 5 sine theta is equal to -4. So you can have that one somewhere, learner. The easiest way of doing this, you just take a photo of the question, then you can do it later. It's also good you do a lot of practice, because if you don't do a lot of practice, when we resume, it's like you'll be starting from negative zones. Negative zones, I hope you know where those negative values are found on the number line. So we can move on. There's another example here. Given that sine 90 minus x is equal to 0.8, where x is an acute angle, you find without using mathematical tables the values of tan x. So you can also do this one. You can work out the fourth example, learner, there at home. Just take a photo of this and you'll be good to go, because we have to focus more on the graph. 10 marks. Graphs, 10 marks. There's another example here. Solve the values of x. The range of x is given from 0 degrees to 360 degrees if 3 cos squared x minus 7. I think this is the same as the other question that I'd given you. So we have our next example here is now the graph. Wow, very good question here, learner. This is our last example. I'll be spending much of my time explaining this particular question. 10 marks. The table below shows some values of the curves y is equal to 2 cos x and y is equal to 3 sin x. So the first part is to complete the table for values y is equal to 2 cos x and y is equal to 3 sin x. Correct 1 decimal places, 3 marks. On the grid provided, you draw the graph of y is equal to 2 cos x and y is equal to 3 sin x. The range of x is given 0 degrees to 360 degrees on the same axis. So that means we shall be drawing these two curves on the same axis, on the same graph. Then finally, we shall be using the graph to solve this particular equation, 2 cos x minus 3 sin x is equal to 0. So if you look at this, 2 plus 5, that is 7, 7 plus 3, you get 10 marks. And these are the questions that you should be expecting to encounter in any given exam in mathematics. 10 marks. These are questions from section 2. So let's quickly fill this particular table. Here now you need to have your calculator. You need to have your calculator. These are all degrees, 90 degrees, 120, up to the last degree, which is 360 degrees. We are using 360, 0 to 360 because that is the range that was given, 0 degrees to 360 degrees. So let's work out this, learner. Let's work out these. And we can start with the first one, 2 cos x. So it's good you also try and find out whether the values that they're giving are correct. So for me, I will also get hold of my calculator and work out 2 cos x. Our x here, these are the values of x. The first value of x is 0. So I'll just have 0 to confirm. If I work out 2 cos 0, the answer should be 2. And it is true, 2 cos 0 is 2. Now let's move on to the next angle, 30. So you replace x with 30, you'll have 2 cos 30. That will give me 1.7. So remember, we were told to get the values correct to 1 decimal places. So I'll have 1.7. Very good. So there's no need of me confirming 60, 90, because already you have confirmed that their values might be right. So we just need to move on to the next angle, which is 120. Let's work out these. 2 cos 120. You get negative 1. Very good. Negative 1. The next is 180. Let's work out these. If you work out 2 cos 180 degrees, you get negative 2. Very good. Next angle is this one here, 270. Remember, this is the function that we are using. We are only replacing the value of x, which is now, for this case, is 270 degrees. So 2 cos 270, that will give us 0. We are done with the first function. We can move to the second function, which is 3 sine. Let's confirm this one first. Confirm sine 0, whether you'll get 0. Yes, it's 0, and that is what they are giving us. So to save time, we'll move to 60 to get the values here. So you'll have 3 sine 60. Yes, my learner is telling me that is 2.6. Very good. Let's move on to 150 very quickly. 150, that is 3 sine 150. That is 1.5. Thank you. Let's move to 180. 3 sine 180. You get 0. Next is 210 degrees. You get negative 1.5. Let's move on to 270. We have negative 3. And finally, 300 degrees. You'll have negative 2.6. And that is it. You get your 3 marks. Just as simple as that, learner. Very simple indeed. Very simple, simple indeed. So we can now move on to the graph. Since we don't have, or I don't have a graph here, I have a whiteboard. But for you, learner, I can give you like 5 seconds. You get a graph paper somewhere. Get a graph paper and see how you can draw a very good graph for this particular question. So here I'll have my title. Remember, a graph must have the title. So I'll be having a graph of y against x in capital letters. Then you underline. You must use a ruler to underline. Then I hope now, learner, you have your graph paper. We can continue. Have the x-axis. You can have the x-axis and the y-axis like that. So we have the x-axis. The x-axis, we can have it like that. Mine here is a sketch. I hope for you, learner, you have your graph paper. Y-axis. You remember on the x-axis we had the angles. The angles here was from 360 to, it was from 0 degrees to 360 degrees. So the scale here, if the scale is not given, make sure you choose a very good scale that will occupy at least 3/4 of that particular space on the graph paper. So the scale, we can say, let's have 1 centimeter to represent 30 degrees. So I can have my 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150, 180, 210, 210, that is 240. We are adding 30, that is our scale. That is 40 plus 30, that will give us 270, plus 30, that is 300, plus 30, that will give us 330 degrees, and finally 360 degrees. So our scale, the scale should always be at the top right. So the scale here on the x-axis, we are using 1 centimeter to represent 30 degrees. Of course, this is the origin. Then on the y-axis, as you can see, the highest value here, the highest value is it 1.7? The highest value, and the least value is -3. So we can say, let's have that as 1, 2, 3, -1, -2, -3. So on the y-axis, this is my scale. 1 centimeter is representing 1 unit. So I've just skipped one box here. I'm assuming that this is my 1 centimeter to represent 1 unit. So far, we have 3 marks. One is for the title, another mark is for the scale, another mark is for labeling. You have to label that this is y-axis and this is x-axis. Let's start with the first graph. The first graph here from 0 to 2. When x is 0, when x is 0, y is 2. When x is 0, y is 2. So where is that particular point? When x is 0, y is 2. This is the point. Let's go back. When x is 30 degrees, the value of y is 1.7. So 30, 1.7. 30, 1.7. 1.7 approximately should be somewhere there. Next, 60. Yes, 1. Now my learner is with me here. 61. When the angle is 90, the value of y, I'm told it's 0. When x is 120 degrees, y will be -1. So you'll have -1. Of course, -1 approximately should be there. 150 degrees, when x is 150 degrees, y should be -1.7. Approximately that should be somewhere there. So mine is just but a sketch. But for you, learner, I'm sure you have a graph paper with you. So your graph should not be like mine here. Mine, I'll just have a sketch. Next, we want to move to 180. 180 is -2. 210, -1.7. Good. When x is 240, y should be? When x is 240, y is -1. So we have to get -1 somewhere there. 270 is 0, as you can see. So 270, 0. 300 is 1. Very good. 300 is 1. Approximately should be somewhere there. When x is 330, y should be 1.7 approximately. If this is 1 to 1.7, should be somewhere there. Finally, when x is 360, our y should be 2. So Now you can join these particular points to form smooth curve. So mine, I've told you it won't be a smooth curve because I've just been trying to guess these values. But for you learner there back at home, you have a graph paper. So don't laugh at my graph and say, Mwalimu, yours is not smooth, therefore mine is also not smooth. No, mine here, I'm having a whiteboard. So let's try and join. I'm sure learners will be laughing at what I'll be having. So since I don't want you to laugh at my values, so this is what I will do, and I will, so don't worry. So this is what I will do, learner. I will now have mine. I will now have my graph. Now, since we are teachers, we know how to maneuver around this. I can now insert back my values. Though they may not be accurate as yours there back at home, but this is just but a sketch. Then you label this particular curve. You label this was y is equal to, can you remember this was the first function, y is equal to 2 cos x. You label this is y is equal to 2 cos x. We are done with the first curve. Let's move to the second curve. So we shall be using these values in the first row and the values in our third row here. So when x is 0, y will be 0. So let's now again draw that on the same axis. When x is 0, y is 0, that is the origin. Now next 31.5. So 1.5 should be in between 1 and 2. So approximately there. Next 60 degrees. What is the value of y? Learner 2.6. Very good. 62.6. 2.6 should be somewhere there. 90. Learner. Yes, very good. 90. We have 3. This is 120. Yes, 120. 2.6 should be somewhere there. 150. 1.5. That was 150. So I can wrap this and say 150 should be somewhere there. 180. When x is 180, y should be 0. Very good. When x is 210, negative 1.5 should be somewhere there. Negative 1.5. Then that was for 210. 240. When x is 240, it's here. When x is 240, y is equal to negative 2.6. Negative 2.6. Negative 2.6 should be, where is that 2.6? Just a minute. Negative 2.6. Negative 2.6 is here. Negative 2.6 should be down here. Next, 270. When x is 270, y should be negative 3. Very good, learner. I can see we are very sharp learners here with me. When x is 300, negative 2.6 should be somewhere there. When x is 330, y should be 0. And finally, when x is 360, y should be when x is 360, 360 is 0. 360 is 0. I hope this one is negative 1.5. So negative 1.5. Then join and see what you will get. Just join and see what you will get. So as I told you, I will also do away with this. I hope I will not forget where those points are. So learner, I'm sure you have a very smooth curve back at home. You have a very smooth curve. You have a very smooth curve there. So let's now join. So I will have to rub this one because I'm trying to get my points because I had earlier done away with them. This is just but a sketch, learner. Yours, I'm sure it's one of the best curves you have. So you need to label this, which is y is equal to 3 sine x. Y is equal to 3 sine x. So here, learner, you will get 1 mark for the title, 1 mark for the title, 1 mark for the scale. You also have 1 mark for labeling. You have to label. For you to label, you just say y-axis, x-axis, it must have an arrow there. Then you also have another mark for plotting. For plotting, you can have another 1 mark. Then this last 1 mark is very difficult to get it. That is accuracy. Accuracy, you get another 1 mark, totaling to 5 marks. So for this one, if your curve was not smooth, then don't expect this 1 mark for accuracy. Don't expect that 1 mark for accuracy. So that is the graph. You get your 5 marks. Remember, we had earned 3 marks somewhere by completing the table. Now we need to go to the last part of this particular question. Use the graph in B to solve the equation. So this equation, 2 cos x minus 3 sine x is equal to 0. So this one, it's very simple. 2 cos x minus 3 sine x is equal to 0 is the same as 2 cos x is equal to 3 sine x if you take this on the other side. So this, if you look at this particular first part, is the first graph that we drew, this one, and this is the second graph. So that means the point at which the first curve is equal to the second curve is the point at which the 2 curves are intersecting or meeting. As you can see, these curves are meeting at this particular point, and also they are intersecting at this particular point. So you need now to give your values. X will be equal to the first point. Now you have to drop downwards and get the values of x. So for me, mine here, my x approximately, it will give me 30 degrees. But for your case, it could be 28 or 29 or 31 or 32, depending on your accuracy. So mine, I'll guess it's 30 degrees. And then let's move to the next one. The next point where the curve is intersecting. It's intersecting at this particular point. Therefore, which point is this, which point is this, which point is this? Approximately, learner, back at home, I'm sure you have the best curve, so you have the correct value of x. So mine here, I can say it's in between. It's very close to 210, and this is 240, so it could be 220 there. That is my approximation, 220 degrees. So these are my 2 values that will give me 2 marks, 1 mark for that particular value and another mark for that particular value. So dear viewers, and especially the candidates, actually that marks the end of our lesson today. And before we just end, it's also good to do a very quick recap. We started by looking at the first identity in Form 4, Trigonometry 3, and we said sine squared theta plus cos squared theta is equal to 1. And we also looked at the second identity, tan squared theta is equal to sine squared theta, over cos squared theta, and we applied those two identities to solve simple equations. And then we also looked at the graph, and on the graph we have said there are only 3 parts there. There you can be asked to fill the table. You get 2 to 3 marks. Once you have the table, you can now transfer the values from the table to the graph. You get 4 to 5 marks. Then once you have your graph, you'll be asked to get some values. You'll be asked to get some values like the first function is equal to the second function. So basically that is the point where the 2 curves are intersecting. Then you can also be asked to get the amplitude and the period from the graph. So I don't know if we have some questions that our dear viewers have sent. So I don't know if we have those questions. So since we, I can see we have Dr. Timothy Amoka is saying this is my former classmate at Shisasari Primary School there in Western. Is saying he's tuned and he's watching, and also the Danon's High School family is also watching. Mr. and Miss Danon's 2020, they are also watching. So thank you very much, the viewers. Until we meet next time, for me, I say